All right, today we want to look at some mathematical formulas and their work and power in integrated science. All right, let us take work. But before we look at the formulas, let us define work. When we say work is said to be done when a force moves a body through a distance in the direction of the force. Now, mathematically, from definition of work, we can say that work done, let us use capital W to represent it, all right? So work done is equal to the force acting on the body times the distance through which the body moves. Let's use D to represent it. So in short, we can say that W is equal to F times what? D. In some cases, we can give you work done, give you distance, and ask you to find force. So making force the subject, we can say force is equal to work done over distance. We can also make distance the subject, as distance moved by the body is equal to work done all over what? Force. So these are some formulas that we can also have under work done. All right, let us move further. Now, if work done is equal to force times distance, there are some instances where the force will not be given to you. But we also need to know that force can be equal to mass of the body times acceleration due to gravity. So F equal to mg, where m is the mass of the body, J is what? Acceleration due to gravity. So in that case, we can say work done is equal to mass times gravity times distance. Now, in some cases, where we have the distance, we can use height to represent it. So we can also introduce h, all right? In place of the distance, we can put h there. Again, if force is equal to mass times gravity, we can also say from linear motion and from Newton's second law of motion, all right, force can also be equal to mass times acceleration. Therefore, we can say that work done is equal to mass times acceleration times distance. So we can have these formulas, formula number 1, formula number 2, formula number 3. A question can be given, all right? We can give you work done, gravity, distance or height, and ask you to find mass. So when it happens, we just make mass the subject, as mass is equal to work done all over gravity times height. All right, we can make anything the subject. Here too, we can even make acceleration the subject. So acceleration will be equal to work done all over what? Mass times what? Distance, as we can see. Now let us look at the difference between acceleration due to gravity and acceleration. Now, gravity is constant, all right, and that is 9.89 meters per second squared, or approximately we can say gravity is what? 10 meters per second squared. So anytime they give us a question and we want to use gravity, we can use any of these numbers in place of what? G. All right, let us look at the unit in which these quantities are measured in. First of all, work. We need to know that work is measured, or its SI unit is joules, all right? That is capital J, all right? And we have mass. The SI unit for mass is in kilogram, which we need to take note of that. Now, our height, the unit for height is in meters, all right? And what again? Our force, the unit for it is in what? Newton. Don't forget, if the mass is given to you in gram and you want it in kilogram, you just divide it by 1,000, all right? And again, if the height is given to you in centimeters and you want it in meters, you divide it by 100. All right, so I think with this unit, with these formulas, we can do any calculation that we want. And last but not the least, acceleration is measured in meters per second square. So these are some few units for our quantities that we can have. All right, Let us look at power. Now, when we say power in science or in physics, what does it mean? We say power is the rate at which work is done, and it is measured in watt. All right. From this definition, we can say that power is equal to work done. So let us use P to represent it. All right. Power, P, is equal to work done divided by, that is, time taken, our time, T. All right. So we can say P equal to W over what? T. But we know, because sometimes the work will not be given to you. So we know that our work done is equal to force times what? Distance. All right. Therefore, we can say that power is equal to force times distance all over what? Time. So we can also have this formula for what? Power. Again, where we have work done is equal to mass times acceleration due to gravity times height, we can also arrive as power is equal to mass times gravity times height all over what? Time. Again, we can also say that where we have work done is equal to mass times acceleration times distance. All right, we can say power is equal to mass times acceleration times distance all over what? T. So these are some formulas that we can also have under power. Now, a question can be given. We can give you power, give you time, give you gravity, give you height, and you can be asked to make mass the subject. And in that case, we can say the mass of the body will be equal to power times time all over gravity times what? Height. So we can do change of subject from this angle. We can also be asked to find the distance moved by the body. We can say the distance is equal to power times time all over mass times acceleration. So these are some few formulas that we can have. Let's see how we can use these formulas to do some calculations.